Because we take internals first as usual. So key near internals. Okay, so today we do the questions of ideal gas. Again, we try to understand the concept better. So I think that day we did the assignment questions. We did together. So now left with one question, right? So we go ahead, try with that, the last question. I don't know how many of you tried. Anyone tried the question, the last one? So all focusing to AS. So just continue with the AS. Okay, let's we do together last question. Then we go ahead discussing more questions from other sources. Okay. Okay. So we go back. Oh, this one. Oh yeah, okay. So last question. Okay. So recall back all the formulas. How to do the last question? Again, 2 minutes. So first equation is what? PV over T is constant. Second equation is what? PV equals to what? N RT. Okay, RT. Then the third one is what? PV equals to what? N KT. NKT. Then after that, from kinetic theory, you get what? PV equals to 1/3 and mc squared, and m mean square speed. Okay, and the last one is what? Kinetic energy, the highlight of this topic. Kinetic energy of a particle is found to be 3/2 kT. This kinetic energy, you have to say, is a mean kinetic energy. It's a mean kinetic energy, average kinetic energy. In exam, you forgot to say average, you lose mark. You just said it's just kinetic energy of a particle, you lose mark. So you have to say mean kinetic energy. Okay, because at a particular temperature, all of the particles have a range of speed. So this is the mean kinetic energy. Okay. Okay, based on this, can you get the answer for 1.04 times 10 power negative 20 joule for this question? Give you 2 minutes again. My expectation is A2, just try to understand the class of the concept. Okay. So container hold a mixture of hydrogen and oxygen in the thermal equilibrium at a temperature of 500 Kelvin. Given that the mass of hydrogen molecule is 3.34 times 10 power negative 27, oxygen is 6 times more massive. Find the mean translational kinetic energy of both type of molecule. So what is the mean kinetic energy of both type of molecule? Do both of them have the same kinetic energy or different kinetic energy? Both of them have the same kinetic energy, right? How do you know that? Because they're exposed to the same temperature. If any particle, regardless of whatever mass it has, if the temperature is the same, they possess same kinetic energy. That's a fact we learned. So of course, part 1, find the kinetic energy of both type of molecule should be the same. So of course, 3/2 kT. 3/2 kT is used, right? So we don't care what mass is possessed. We don't care what speed is traveling. As long as we know the temperature, we can find the kinetic energy. 3/2 kT. Okay. The temperature should be, of course, 500 Kelvin. Okay. So 3/2 K Boltzmann constant. Okay. Boltzmann constant is Boltzmann constant. 1.38 times 10 to the power of -23. Calculate now. Come on. 1.38 times. All constants are provided. You don't need to memorize. So K is 1.38 times 10 to the power of -23. Okay, hope you got already got down. -23. Okay, let's go down. Yeah. Okay, now can you find the kinetic energy? So you get 1.04 times 10 to the power of -20. Yes. 1.04 times 10 to the power of -20. Yes. So 3/2 kT. Formula, Coulomb formula to find kinetic energy of a particle. Mean kinetic energy of a particle. Okay, so as I said, scientists first find the kinetic energy of the particle by using the temperature. Then only they worked out back ways to find what speed is traveling. Okay. So can you go to the 2 now? Find the RMS speed of both types of molecule. So RMS speed, root mean square speed. Okay. The more massive particle should have possessed a less RMS speed. Okay. RMS speed is like an average speed, root mean square speed. Okay. But realize this is your mean square speed. This is your mean square speed. Root this, you get the root mean square speed, right? So find the mean square speeds first. No choice. You want to find RMS speed, you have to find the mean square speed first. Because all the formulas, only the mean square speed is known. Okay. So get the mean square speed first. Then root the mean square speed, you get RMS speed. Get the working. So kinetic energy, So yeah, the kinetic energy should be equals to what? Equals to half m, okay, mean square speed. It's equals to this value, right? This value. So you find the mean square speed first one, right? Find the mean square speed first. Mass is given in terms of kilogram. Then root it, you should get 2,506.24. Right, so mean square speed is what? Mean square speed is 2V over M. 2V over M, you get the mean square speed. Oh, sorry, what is that? 2V. 2 EK, sorry. Yeah. This is 2 EK. 2 EK over M. Kinetic energy is 1.04, right? Okay, another 1 minute for you. Get the working. Okay, so all of you got the answer. Now let's go to the passes. How in ideal gas, how the question has been asked. We're going to kind of a discussion, but my expectation when you read the question, just figure out what formula, how what you think, how you're going to handle. If it gives 2 marks, you need to get 2 points. Okay, elaborate more. Okay, the answers. Okay, so these equations in your mind is 5. Okay, you go to the passive. So in the times I put the topical passes for this ideal gas. Okay, so you can check that. Yeah, so this is the passes. It is some passes final guess. Okay, so as we come across, understand more about ideal gas by questions. Okay, the first question. The kinetic theory of gases leads to the equation of half mc squared is equals to 302 kT. Yeah, the kinetic theory of gases, the theoretical scientist figure out it should be 302 kT. So explain the significance of the quantity of half mc squared. What are you going to write? Explain the significance of the quantity of half mc squared. What is meant by half mc squared in this context? 2 points in your mind. It's 2 mark question. 2 marks. 2 mark question. Okay. Yeah, 2 points. What do you think? It's a mean kinetic energy. It's a mean kinetic energy of one particle. Okay, it's a mean kinetic energy of one particle. Okay, so half mc squared is the mean kinetic energy of one particle. Okay, in a gas. So that's the answer. Okay, so you just say kinetic energy, lose mark. Mean kinetic energy. Okay, mean kinetic energy of particle in a gas. Okay, so mean kinetic energy of one particle. Okay, so that's what expected. I don't know how many of you thought of mean kinetic energy. You said kinetic energy, maybe you get 1 mark, but mean kinetic energy. Don't forget the word mean. Why mean? Because as I told you, at one particular temperature, scientists found all the particles move in a range of speed. Okay, so we average it out. So this is a mean kinetic energy. Okay, good. Those who thought of mean kinetic energy. Okay, 2. What do you think you answer? Use the equation to suggest what is meant by absolute zero of temperature. Absolute zero. 0 Kelvin. What is meant by 0 Kelvin? What is happening at 0 Kelvin? Anybody? Absolute zero. What is meant by absolute zero? What is happening at that temperature? The particle possess zero kinetic energy. Okay. So absolute zero is a temperature. Absolute zero is 0 Kelvin, where the temperature is a temperature where the particle possess zero kinetic energy. Okay. So it's now solid now at room temperature. We don't see it's moving, but the particle is vibrating. But even the vibration stops at 0 Kelvin. Okay, they possess zero kinetic energy. That's the idea. So what is absolute zero? The temperature where the particle possess zero kinetic energy. Don't say the particle possess zero energy. Wrong. Is it particle has zero energy at 0 Kelvin? No, it has possess some energy. What type of energy possess? Anybody? At 0 Kelvin, what type of energy might possess? Potential energy. Might possess potential energy. Kinetic definitely zero, but it has potential energy because due to the intermolecular force, it has potential energy. Okay. Yeah, but kinetic definitely zero. Okay. So now we go for how are you going to use the formulas? The 4 formulas you come across. You see this question. Two insulated gas cylinder A and B connected to a tube negligible volume. I want you to calculate roughly. Okay. So two tubes A and B tap. Okay. So scroll up. Let's go down. Okay. So got it. Come on. In your mind, figure out what formula. What do you think? How do you think will go up for this? Each cylinder has an internal volume of 2 times 10 to the power negative 2. Each got 2 times 10 to the power negative 2 meter cube of volume. Initially, the tap is closed, and cylinder A contains 1.2 mole of an ideal gas at a temperature of 37 degrees Celsius. Cylinder B contains the same ideal gas, same type of ideal gas, at pressure 1.2 times 10 to the power 5 Pascal. Okay, and temperature 37 degrees Celsius. Both temperatures same. Cylinder A contains 1.2 mole. Cylinder B, we don't know how many mole it has. Okay, but the pressure contains the same ideal gas at pressure 1.2 times 10 to the power of 5 Pascal. Pressure for both container must be the same, right? Oh no, the number of mole we don't know. We don't know how much of number of mole of gas trapped inside. A was 1.2 mole. B we don't know how many mole. So pressure not sure yet. Because pressure depend to what? Pressure depend to the number of particle, right? Okay, more particle, more pressure. Okay. Both container have same temperature. Both container have same volume. But both container, do they have same number of mole? We don't know. We only know A number of mole. B number of mole, we don't know. Okay. If B number of mole is higher, then the pressure at B should be higher. Right? Okay. So now question. Okay, the first question. Okay, please calculate. What do you think? Which formula is suitable? Calculate the amount in mole of gas in cylinder B. How many moles contains in cylinder B? So what formula suitable? Yeah. PV over T constant, PV equals to nRT, PV equals to nKT, PV equals to 1/3 nmc squared, kinetic energy 302 kT. Which is the best? 2 minutes for you to think. Please calculate roughly. Maybe you take a piece of paper, can calculate. Okay, come on, calculate out. Tell me the answer. I want you to learn the idea, which formula is suitable and how it goes about. So they want number of mole in B. Okay, B is a closed system. B itself is a closed system. Okay. So I want the answer from you. How many moles? Give me the answer. No, how many moles? 0. 0.93. 0.93 mole there. Okay, let's see this there. Then friend got 0.93 mole. Zero 0.93 mole. Okay, yeah, this got 0.93 mole. 0.93 mole. So, what formula to be used? For the cylinder B, you know the temperature. You know the temperature 37 degrees Celsius. You know the pressure, you know, is 1.2 times 10 to the power 5. You know the pressure, you know the temperature, okay, you know the temperature, you know the pressure, you know the volume. Of course, you know the volume also, you know. Yeah, so the formula is PV equals to nRT or nKT also can be used. But because they want number of mole, I think the most suitable is PV equals to nRT. So the thought of PV equals to nRT is good. Should be PV equals to nRT because we want number of mole, right? So we know pressure, we know volume, we know temperature. So you can find the R. N. R is constant. It's always 8.31. Okay. The constant you can check from the notes. Okay, from the notes. It's 8.31. That's a constant given in exam. Another trap, 37 degrees Celsius, change to Kelvin. So 37 plus 273.15, right? 273.15 should gives you the answer. So then check the number of mole. 0.93. Is it? Actually, I'm not interested to the answer. I am interested to the flow to get the answer. So we thought of PV equals nRT. We thought of temperature need to be changed to Kelvin. Okay. Yeah. Good idea. So 0.93. Anyone got a different answer? 0.93? 0.93, yeah? Okay. 0.93. Okay. Okay, now. Come on. Grab this. How do you solve this? The tap is open. The pressure between the two A and B, is it the same? Can it be the same? The pressure A and B cannot be the same. Why cannot be the same? Because they have different amount of what? They have different amount of mole, right? So they have different amount of number of particles. The one which has greater number of mole must have greater pressure. Because the volume same, temperature same, everything same, but more mole means more pressure because more particles are colliding to the wall. So pressure is different. When you open the tap, what happened to the gas? The gas will flow from high pressure to low pressure. The particle will redistribute themselves until what happens? Until the pressure become the same both sides. Okay. Last time the B alone is a closed system. A alone is a closed system. Now when you open the tap, the A and B together become a closed system. A and B become a closed system. You can't go for B anymore as a closed system because it already mixed with A. When you open the tap, A and B together is a closed system. The law applies for a closed system. Okay. Okay, so let's see how many of you can get the answer. Earlier was 0.93 mole contained in the container B. Okay, please calculate. Using the fact that the total amount of gas is constant, determine the final pressure of the gas in the cylinder. When you open the tap, all the particles mix up. What happened to the pressure in the gas? How much? So I scroll up for you the information. So hope you understand the question. Okay, tap is open. Okay, so come on, work out. This is the information, Tap is open. The cylinder A has 1.2 mole of gas. Cylinder B has 0.93 mole of gas. Mix up. So what is the new pressure? So what formula to be used? Okay, this is interesting. I want to see who can get the answer for this. Tell me answer. Just give a try. Wrong, never mind. 2 minutes for you. Okay, minimize this so that we can see the questions. I can see the question. It's too small. See, right? Okay, see the questions. I want to answer in 2 minutes. Try to work out. Okay, first, what formula is the most suitable? PV equals to nRT still can be used. You go to PV equals to nKT or kinetic energy, which is the best? Calculate. The R is 8.31. The R is 8.31. I think you have used PV equals to nRT, right? Still relevant, right? PV equals to nRT should be used, right? Pointless go for PV equals to nKT. You want to go for nKT also can, but number of particles, you need to find number of particles, more work. Because already number of mole, PV equals to nRT. Okay, so formula must be PV equals to nRT. So, yeah, should be again PV equals to nRT. But now the two container is together as a closed system. Okay, the two containers together, A and B is in a closed system. This is a closed system. Okay. So pressure is how much? You're looking for the new pressure, right? Okay. Volume how much? Volume you put how much? Volume is 2 times 10 power negative 2 times 2, right? 2 container. Yeah. The total volume of the system, the closed system is 2 times of 2 times 10 power negative 2. Yeah. That should be the volume, right? I don't know how many of you put 2 times. So here should be 2 times of the volume above, because 2 containers, the total volume. So 2 times 2 10 power of negative 2, 10 power negative 2, sorry. That should be a volume. Okay. Okay. N is what? Number of mole? Number of mole? Because A and B now combine the total number of mole. So the total number of mole was what? 1.2 plus the 0.93. That's the total number of mole of the gas. So N should be what? N should be the total number of mole. 1.2 plus 0.93. 0.93 is the number of mole. R we know is 8.31. Okay, and we find the temperature. Temperature for both bodies is the same. 37. You open the tap, also temperature won't change. Okay, so same temperature, because they already achieved thermal equilibrium temperature. So the temperature is still going to be remain 37. So it's 37. Of course, changed in Kelvin. So plus 273.15. 273.15 will give you the pressure. Okay, so I don't know how many of you thought of this. First, PV equals nRT, you selected. Second, you aware that volume must be double container. Okay, because the A and B together is like a closed system. So the both volume is together is the volume we kept in this region. The number of mole both need to be added. You are aware of that. The temperature is the same, so temperature never changed. 37 and 70.5. Able to get the pressure, final pressure. Okay. So that should be the working final answer should get. Okay. So again, answers aside. So the focus is how to get that answer. Okay. What formula, what to substitute. That's the idea we are building up. Okay. Okay. So as we move on to other questions, try to build up the idea. What equation, what to be substituted. Okay. Okay. This is gravity. Okay. I don't want to go to gravity yet. Yes, come on. Kick in. Next question. Figure out what formula, how do you go about, what volume, what information you submit. 2 minutes for you. Select the correct equation, get me the answer. What is the temperature in Kelvin? Is it PV equals to nRT, PV equals to nKT, or CO2 KT? Which one to be used? Okay. Determine the temperature of the gas after the compression. So what formula comes to your mind? The correct selection. I just want the final answer. How many temperature? Okay, anybody got the answer? What Kelvin? You want in Kelvin. You select the correct formula. What formula to be used? Do you use PV equals to nRT? Yeah. Can't use PV equals to nRT, right? Because number of mole not given. They never ask for number of mole also. Because two sets of reading is there, so P1 V1 over T1 equals to P2 V2 over T2 to be used, right? So those who thought of that equation is good. This should be P1 V1 over T1 equals to P2 V2 over T2 because two sets of reading. Pressure, volume, temperature for the first set given. Then second set, volume and pressure given, they are asking for temperature. So P1 V1 over T1 equals to P2 V2 over T2. Okay. So this the formula should come to your mind, right? P2 V2 over T2. Then just find the T2, right? Find the temperature in T2. That's all, right? Selection of equation. P1 V1 over T1 equals to P2 V2 over T2. P1 V1 can be any unit you like. You change the volume to, what is the volume given? Centimeter cube. You change to meter cube. Okay. Did you necessary to change the meter cube? Yeah. No need. Identical formula, the unit you can put whatever unit you like. Yeah. Except temperature. Temperature must be Kelvin. Yeah. So here you want to change the meter cube, can, but more work. Convert also you get the same answer. So volume, those expert won't change. Leave it as centimeter cube. Okay. Pressure, whatever unit you give Pascal, so leave it as Pascal. The temperature change to Kelvin. So the 27 degrees Celsius change to Kelvin, so you get the T2 in Kelvin. One answer you got. Anybody? How many Kelvin you got? What's your? 98.5 Kelvin. 98. Anyone calculated? Okay, so again, I just want you to know the method. What equation? So you can get the answer in the temperature. I think your friend got 98.5. Okay, so important is the formula and how to substitute. Okay, let's continue. More exposure. Part B, first law of thermodynamics is the next topic because as I told you, 3 topics together interrelated. So we skip this thermodynamic for time being. Next topic you get to know what is meant by thermodynamic. Okay, so next question. Come on. So 2 marks. Can you get the 2 marks? What are you going to explain? The pressure P of an ideal gas is given by that question. Explain meaning of the symbol C squared. So what is that? Many times I told you, right? It's a mean square speed of a particle, okay, in a gas. It's a mean square speed of a particle, okay, in a gas. So mean square speed of a particle in a gas. You should get 2 more. Mean square speed. The highlight of the topic, highlight of what type of speed is very dominant here, very famous is mean square speed. Not root mean square speed. Just mean square speed is the famous because that's the one linked to the temperature. Okay, come on, B1, complete. Figure out what formula to be used. This one, I think you have to use the kinetic theory equations. PV equals to 1/3 nmc squared. I think first time. Come on, give a try. How are you going to use that? The ideal gas has a density of 2.4 kg per meter cube at a pressure of 2 times 10 to the power 5 Pascal, and the temperature is 300 Kelvin. Determine the root mean squared speed of the gas at 300 Kelvin. Okay, figure out which formula is the best. Density was given. Density. I think there is one formula with the density, right? The 1/3 nmc squared we converted to density, right? Okay, recall back what formula is that? Can be used? Pressure given, temperature given, density given. But temperature given. The one the root mean square speed. You know temperature, you know pressure, you know density. You're asking for root mean square speed. So we can't directly find root mean square speed. We find mean square speed first. Okay, we get the mean square speed. Okay. How you can find the mean square speed? What formula linked to mean square speed? I think you know P equals to what? P equals to 1/3 rho C squared. You know that another one formula. Right, this is another one formula. But can we use this formula? Do you have enough information? You know Pascal. You know pressure. You know density also, right? Yeah, good. I think suitable, right? Do you remember this formula? This formula is formed from where? PV equals to 1/3 nmc square, right? Nmc squared. Yeah, nmc squared. The original formula from kinetic theory. So the nm over the v, right? Over v. Put the v down. Yeah, it turned to become P equals to 1/3 rho c squared. Correct. Yeah. So this is the formula must come to your mind. Yeah. P equals to 1/3 rho c squared. Yeah. To find the c squared, square root it, get root p squared. Yeah. So those got this equation. P equals to 1/3 rho c squared. Okay. Right track. Yeah. Okay, so find the mean square speed. Then whatever mean square speed you got, just square root it. You get the root mean square speed. Okay, so again we are going for the idea. Actually, at the back got mark scheme. So the working you can build up later. Important is the idea, what formula to be used. That's the main thing you need to develop. Okay, think number part 2. Can you figure out which formula to be used? Part 2. What equation to be used? Calculate the temperature of the gas for the atom to have an RMS speed that is twice that of calculated in one. Calculate the temperature of the gas for the atoms to have an RMS speed that is twice that calculated in one. This is interesting. Calculate the temperature of the gas for the atom to have an RMS speed that is twice that calculated in one. Okay, let's say calculated in one. Let's say you got, I put a number. Let's say calculated one is V. Let's say first V RMS is V. Okay. So RMS. Okay. Remember mean square speed. Okay. Then temperature, right? I always draw these 3 columns. Okay. I want you to highlight. Don't forget the mean square speed. So they said the first mean square root mean square speed. Let's say you got V. Okay, I put a number. Let's say you got a number. Anyone got an answer for that? Root mean square speed. What's the answer you got? Anybody? What should I calculate? Okay, let's say I put a number. Let's say I put here 50. Let's say it's 50. So RMS speed 50 when the temperature is what? What is the temperature? 300 Kelvin. RMS is 50 when the temperature is 300 Kelvin. Okay. Now what do you want? What do you want? Find the RMS speed. Find this RMS speed. This X. Find this X when the temperature. Find the. Oh no. Find the RMS speed that is twice. Find the temperature, or they want the temperature. Find the T, that's temperature. And the RMS speed is how much? RMS speed is twice, so 100, right? 100. This is the story, right? Find this temperature. The RMS speed is twice, the earlier one. 50, 300 Kelvin. 100, how many Kelvin? That's the question. Okay. So how do you find the T? You can't directly connect RMS to the temperature. Only the mean square speed can connect to the temperature. So what do you have to do? You need to find the mean square speed first. You need to find this mean square speed first. So if 50, the mean square speed is 50 squared, right? 50 squared. Okay. So if 50 squared down 100 going to be down here is 100 squared, right? This is where they are proportional. These two are proportional, right? These two are proportional. So can you find the temperature? Can you work out the temperature? This is what you have to use. Mean square speed is directly proportional to the thermodynamic temperature. 50 squared is 300 Kelvin. 100 squared, how many Kelvin? So you find the T. Okay. So 1 divided by 2, right? The same step. Okay. So 100 square, okay, I do here. 100 square over 50 square should be equal to what? T over 300 and T over 300. Okay, so make the T as a subject, so you get the answer. Okay, but the top, I said, I assume 50 now. Doesn't matter. You put V here, 2V also, the V, 2V will cancel. But the technique, you always question, you always ask root mean square for this temperature how much. But you want, you as a student, as a physics student, you should know. You need to find the mean square speed. That only links to the temperature directly to get the temperature. Okay, class. So if you are very hardworking enough, you can go ahead with the AS A2 together. Okay. So you've done a lot of AS already. You are quite happy with your AS. You still got time. You can do A2 together. What you can do, finish off this question. Just check the mark scheme at the back to get better understanding. Okay, go to at the back got answers. So you check the answers. Try to figure out what formula, then go back, check the answers for your better understanding. Then go to the exam mate, that is topical, vital gas, do that. So you have a better idea about this topic. My expectation. Okay, so I stop here. So tomorrow we'll be doing the trial papers. The trial papers for this time. I select one paper for you. I don't know how many papers you done. Okay, I just select one. I don't know. The day we did which one we did that day? The trial exam, not this one. We did August 18. We did August 18. We haven't done. We haven't done August 18. We done. Gen 18, paper 1, Gen 18, we done this. We done this? Oh, we done this, right? Yeah, we done this that day, right? Okay, we discussed this. So Gen 18 we discussed, okay, halfway. So we go to paper 1, July 17. Okay, please take down paper 1, July 17 for discussion on tomorrow, Friday. Try to do paper 1, July 17. Any problem we discuss. In meantime, do the paper 2, July 17 also. Paper 2 carries more mark. So paper 2, July 17, paper 1, July 17. Okay, July 17 for tomorrow. Thanks. Very much.